up until this point, or up to this point, we've been studying kinematics. And kinematics is kinematics is the piece of physics that deals with how things move. So it answers the question, how do things move? And we quantified this. We came up with some equations. We had the vector motion equations, or just the vector kinematic equation, and we used them to get things like trajectory of y as a function of x. We used it to get the horizontal range of an object thrown on level ground. And so we answered these questions all concerning how. We could say where it was, at what time, how fast, what's the acceleration. But now we want to move into a little bit different piece, and we want to move into something called dynamics. And so dynamics deals with a slightly different question. And it's tempting to just say, well, if kinematics was how, maybe dynamics is why do things move? And you would be almost correct. It's not necessarily why things move. So I want to give a little example of how we can kind of get to the central question of dynamics. So imagine that we have a tabletop here. So just some flat tabletop. It's got some legs on it. And let's say that we have an object sitting on the table. That's going to drive me crazy if I don't fix that being down there. There we go. So let's say we have some object sitting on the table. Maybe it's I don't know, some block sitting on the table. And we're just sitting here minding our own business, and then all of a sudden, this block flies off the table. The question you're going to ask, you're not going to go, hey, why is the block flying through the air? You will probably ask, what caused the block to fly through the air? And it sounds very similar semantically, but it's really asking a much different question. If we're asking what caused the block to fly off, we're asking, why is it that the block was sitting still and then all of a sudden it flew off the table? What changed its motion from 0 to flying off the table? And that's really the central question here. It's not why do things move, it's why do things change their movement? So dynamics really answers the question, what causes change in motion? It's the change in motion that's important. We really didn't care that the block was just sitting on the table, but we cared when there was a change in its motion. So that's the central question of dynamics. And the answer is summed up in one word, and it's forces. Forces cause change in motion. And so this brings us to Newton's laws of motion. In dynamics, we go on Newton's laws of motion. And I'm sure we've heard of Newton's laws, maybe just in passing, or maybe you've actually studied them before. But this brings us to Newton's first law of motion. Let's move our table down here. Want some more room. So Newton's first law. What is Newton's first law? So Newton's first law. And I've got it copied here so I don't have to write it all out. But Newton's first law says, a body in uniform motion remains in uniform motion, and a body at rest remains at rest unless acted upon by a non-zero net force. So the last thing for this video, I just want to talk really briefly about what this non-zero net force means. And again, to demonstrate this, we'll go back to our block. I shouldn't have moved it that far down. So we have a block on the table, and so we say, oh, okay, motion, changes in motion are caused by a force. And so then maybe you take your hand and you press down very hard on this block. You apply a force to it from above. Well, if you're applying your force straight down, it's pretty simple to see that the block's not going to move. And you say, okay, well, I applied a force and it didn't change its motion at all, so what's the deal? And the problem is the net force on the object is still 0. When you applied a force, the table itself is applying a force as well. And we'll dive into that a little bit more later, but essentially, we have to have a non-zero net force. So if I push the object this way, then it would move and there would be a net force. A net force on the object that would cause a change in motion. So we'll do some problems as we talk about this, but I just wanted to get the general idea of Newton's first law.